if you run a simulation in Ashes with a default model and a very high wind speed, so this is running at 50 meters per second wind, you will notice that the the wind turbine is not entering shutdown. So it's still producing 5 megawatts and has a certain pitch angle and rotating at the rated RPM. This is not what you would expect. For a real wind turbine, you expect that in very high wind speeds, the blades are going to pitch to feather. The reason this happens is very interesting. I will put a link to a video in the description. But it's actually not straightforward. But anyway, so the point is that you don't get shut down here when you would actually be expecting one. This is because the default controller, which you have here, which you can modify here, is very good for kind of easily tuning the values and getting different controllers, but it doesn't include the feature of shutting down the wind turbine in high wind speeds. If you want to do this, you need to use a DLL, and I will show you how to do this. So you have to come here, click DLL, enable DLL here, and then one DLL that has this feature is the ROSCO controller, which comes with Ashes. So you come here, select ROSCO, and select the ROSCO controller here. This controller needs an input file. The input file depends on which wind turbine you're using. So here, this is the NREL 5 megawatts. So I know that the input file is NREL 5 megawatts.in. This file also comes with Ashes. And you need to do one more thing to the input file actually. So this is the input file itself. You can see NREL 5 megawatts. And there's this line here, line 17, that says shutdown mode. 0, no shutdown, and 1, pitch to max. And by default, this is set to 0. So if you want to have a shutdown procedure, you have to set it to 1 and save your file. And the other parameter that is relevant, or well, I guess there's a few, but this is the section that talks about shutdown. And this here is, well, the pitch angle at which shutdown procedure is going to start. And this is in radians, so that's 25 degrees. Okay, so now that I have modified my input file and that I've saved it, I can press OK. I have to select what is being controlled by my DLL. So it's going to be the generator and the pitch. And okay, maybe I can start back at 10 meters per second and just show the power as well. Okay, there you go. So if I start my simulation now, and if I start increasing my wind speed, so you can see that now we're producing 5 megawatt as expected because I'm above the rated speeds and going at the rated RPM. And if I keep increasing my wind speeds, then this is what you usually get, right? You increase the pitch angle, but the power and the RPM stay the same. But now, if this is working correctly, when we get to 25 degrees of pitch angle, which is what I have here, you should start shutting down the wind turbine. So we're not at 25 yet. I keep increasing my wind speed. Okay, and there you go. So here we start pitching the blades. So the RPM goes to 0 and the power goes to 0. And and now the blades are pitched to feather. So in this case 90 degrees, and they just stay like this, and the wind turbine is stopped. Or actually, as you can see, it's not completely stopped. It's still rotating a little bit this way. And this is a different topic, but this is called idling. And you do this because you don't want the bearings to be worn out always in the same spot. So by rotating the rotor, what you do is that if there's vibrations due to turbulent wind, for example, or to waves, then the bearings are gonna the damage on the bearings is gonna spread over the whole bearings. And if you want to simulate a parked wind turbine, so completely stopped, which is what you would do for example, if you want to do maintenance on the blades, then you have to go to main shaft here and set bearings to locked. Cool. So yeah, so that's it. This is how to model a shutdown procedure in your wind turbine with high speeds. If you have any questions, just yeah, write us a comment or let us know. Cool. See you around.